It is our last lesson of Unit 6. We are on 6.13. This is an application lesson. It's about estimating your reaction time. So today we will be able to collect reaction time data and create a line plot. We will compute with decimals to identify typical reaction times and estimate a total class reaction time. We'll be able to perform operations with multi-digit whole numbers and with decimals to the hundredths. We'll be able to understand that place value system and represent and interpret data. So before we get started, let's do a little warm up. You're going to write greater than, less than, or plus. I think this should probably be an equal sign on your slate or your paper to make a true number sentence. Again, I think that should actually be an equal sign. So we have 638 thousandths versus 6 4/10. Is it greater than, less than, or equal? Then we have 71 hundredths versus 7,100 or 0.1. I'm sorry, I'm messing up. 0.7100. Is that greater than, less than, or equal? And then the last one, 9 and 958 thousandths versus 9.95799. Greater than, less than, or equal? Pause the video, figure this out, and then come back and check with me. For the first one, you should see that 6 4/10 is greater than 638 thousandths. For the second one, you should see that these are actually equal to one another because you could drop these two zeros. And for the last one, you can see that the second digit is actually, whoops, I did that wrong. You got to pay attention. And I did not. If we can see 9, 9, 5, and then if we take a look at that digit in the thousandth place, even though this appears to be larger, it is actually smaller by a very small amount, but it's smaller. So in your math journal, if you turn to the back, there will be an activity sheet 18. I think it might have the initials AS for activity sheet 18, and it's going to be a grab it gauge. So you need to cut that out. Read the directions for estimating your reaction time. If you turn to page 230 in your math journal, you will find those directions. So in this lesson, you're going to conduct an experiment to test your reaction time, or how quickly you react to a stimulus, which is something that causes a response. It actually takes two people to perform this experiment, so hopefully if you are at home, you can find someone to help you out with this. The tester holds the grab it gauge at the top. The contestant gets ready to catch the gauge by placing his or her thumb and index finger at the bottom of the gauge without quite touching it. So if you take a look at this diagram, this person is not touching it yet, and this person is holding it. When the contestant is ready, the tester lets go of the gauge. The contestant grabs it as quickly as possible with his or her thumb and index finger. The number grabbed by the contestant shows that person's reaction time to the nearest hundredth of a second. The contestant then records that reaction time in the data table shown below. Partners take turns to be the tester and to be the contestant. Each person should perform the experiment 10 times using his or her right hand. And again, these are on page 230 for you to reread if you needed. So you'll see this as on the gauge. You'll notice that the times increase by 1/100th second as you go from the bottom to the top. I really do apologize. My words are messed up today. So you can see at the bottom where we're starting, the starting position is 0. And we quickly go to 7, 8, 9, 10, all the way up to 22 hundredths. Contestants should hold their right hand at the starting position without touching the gauge. So you're going to complete this experiment and turn to page 230 and respond to problems 1 through 4 about reaction times. Hopefully you've paused your video at this time and you've done some experimenting. How would you determine your typical right hand reaction time? What do you think you would do there? Think about that. Reflect. Maybe you came up with these ideas. Choose the reaction time that came up the most often. Choose the time in the middle, or even out the times by adding them together and dividing the sum by 10. You could find the average. Which strategy seems most efficient for you? Why? If you have one time that is much slower and much faster than the rest of your times, which strategy will give the best estimate for your typical time? Remember, we're thinking about these 3 possible ideas. If you don't have a time that came up the most often, which strategy will give you the best estimate of your typical time? Once you're reflecting on these, thinking through them, asking yourself and having a conversation with yourself or the partner you're working with. So I want you to review your own data and consider which strategy you think would work best. And then after choosing one strategy, I want you to complete problem 5 on journal page 231. Take a look. It says your class decided on a strategy to identify each person's typical reaction time. Which strategy did your class choose? Why did your class choose this? Of course, if you're virtual, it's what did you choose? Why did you choose this strategy? Find your typical right-hand reaction time using that strategy that you chose. Show your work on this page and tell us what was your typical reaction time? What was your average reaction time? Here I've created a line plot of some 5th grade data. Obviously, it's not a whole class worth, but we have some data here. We range from 900ths up to 2000ths, and we see we've got 2 at the 12, 1 at 14, and 4 at 1700ths, or 17 seconds. Feel free to pause on this slide if you need it to do any of your work. You may have to rewind to come back to this, but what we're going to do is we'll see that the line plot shows individual reaction times to the stimulus. You're going to perform another experiment. Actually, we're not going to do this one because multiple reasons. We're not going to do the hand squeezing. Biggest reason, we're virtual. So question 6, we're not going to do this one unless you want to do it at home, a hand squeezing activity. So you can look through number 6. And it is suggested that you do your own experiment, come up with your own, perform it, and use your own strategy to identify an average. What are some reasons that our predictions are different from the actual total reaction time? What do you think some reasons would be? Jot some of those down in your journal or on a piece of paper. Save those for conversations you might have with your family about this, your friends, or in class discussions. Next, I want you to turn to page 229, and let's take a look at this first problem. It says the data in the table show how many women's shoes of each size were sold at a shoe store in one day. Use the data to make a line plot, then answer the questions. So you can see the data over here. We can see the line here. You need to plot the data and then tell which shoe size was not sold on this day, and then which shoe size was the most frequently sold on this day. Pause your video, come back, and check your work. Okay, here's the line plot using the data to the right. And you can see that the size 6.5 was not sold on that day, and sizes 7.5 and 8 were the most frequently. They sold the same amount, but they sold the most. Question number 2 says to fill in the exponent to make a true number sentence. So you can look at A, B, and C. You need to fill in the exponent to create these numbers. Pause your video, fill them in, come back and check. You should have seen that 3,700 divided by 10 to the second power equals 37. 67,536 divided by 10 to the fourth power equals 6.7536. And 712 divided by 10 to the third power equals 712 thousandths. Number 3, 9 3/5 minus 8 6/7. You need to choose the best answer for this. Don't forget, you need a common denominator. And your answer should have been 26 35ths. And I believe our last one here, Darian has a $20 allowance to pay for bus fare. He is keeping track of his spending in the table. Plot the data from the table on the grid, connect the points with a line, and answer the question. So you see number of rides, money left, and you've got your graph here, and you need to answer the question over here. Pause your video, come back, and check. Darian, you can see the line plot decreases and goes down because The more rides, the less money he has. And we can see that Darian will be able to take 10 rides with $20. 10 rides with $20. Because every ride is worth 2 if you continued that graph. That is the end of today's lesson. Again, this was an application lesson, so it's a lot of work on your part at home to complete this, collecting the data that you come up with. And if you have any questions, remember you can talk to your class, talk to your teacher for more guidance on data collecting with your reaction time.